Oh, hi, good evening. Back again. This is Programmer's Life. Yeah, from our last episode that we had, this is where we ended. We had a basic C++ program. We had a thorough explanation about each bit within the program. So our next session is to try and run this program and see exactly what happens. Now, earlier on I told you should be having compilers on your machine. Hopefully you managed to install any that you wish to. So here I'm using an online compiler. By the way, you can also have one. If you're interested in this one, just go to that link, onlinegdb.com. It supports quite a number of languages. So here I am, and I'm using it with C++. So here we go. You can come. Okay, these guys have a multi-line comment here explaining about their tool, so we shall not need that. So what are we going to have? We shall say hash include iostream using namespace standard. Then down here we can have the main function. Okay, and we shall say cout hey programmers. Can have inline. So I can even have another line. Cout learning programming. Okay, down here I can still have a new line, and I'll say return 0. Okay, so there we go. We are following the basics that we had earlier. We have a library here, one of the major libraries to handle our input and output. This is just a simple program that is not going to do anything much apart from saying, hey programmers, then I'm learning programming. Okay, so what shall we do? We shall come up here and we shall command a run. So definitely I've liked this. Just at the very beginning, if you remember, some time back when we talked about compilation and debugging, we said we are going to encounter a number of errors. Now in programming, however much you are an expert, of course you will always get errors, but of course the level of errors matters. But for starters, yeah, so it is saying somewhere, so the debugger says compilation failed to the following errors. Last time I left you with a question asking explain the compilation process. Okay, here it was, explain the compilation process of a C++ program. So right now, if you had researched about that, then definitely you would be knowing something that says compilation failed. What exactly failed behind that? So it's saying in function int main error cout was not declared in this scope. So remember, in my explanation I said we have what we call a namespace, and a namespace is a container that contains all definitions of specific tools that you'll be using in your program. So in this case, I'm telling the compiler, please refer to the namespace, the standard std, std, so that you get the definitions of the cout. And he's saying, I cannot find what you're telling me to find. You're using something that is not declared or defined anywhere. So actually it even goes ahead, it tells me that cout has to be scoped from the std. So it says it's already an error. Okay, so what does it mean? It means that we wrongly typed the keyword using. Okay, remember I told you last time using is a keyword, and we even talked about it in detail. So once again, we are going to say run. So at the running time, it compiles and it executes. Okay, so it says, hey programmers, I'm learning programming. Wow. So how did they come to new lines? Here we used end line. We shall talk about that in the future, but we use it basically for starters. Each time you want to display an output on a different line, on a new line, that is how you do about it. The same applies to this. Okay, so basically we ended with another statement which is called return 0. I gave you research about that, and I'm very sure you are at par with me. So there we go, we have a basic program. Okay, now back in our session, I'll still start with a question. So I'll say write a program that will print or display your names, age, and NIN number. Okay, based on Uganda's standard, we have what we call national ID. So each national ID has a NIN number. So write a program that will print and display your names, age, and the NIN number. Okay, very sure you can do that. So without wastage of time, I want us to talk about something that is very, very important, and that is what we call variables. Now, each time we write programs, these programs at certain instances, they have to store data, then they have to use data, then they have to retrieve that data after storage. So it means as a programmer, it becomes a requirement that if you're writing a program, this program should devise means of getting the data. Then after getting the data, the program should also have a possibility of storing the data, then use the data at a later stage. Now, each time that data is to be stored, that data is stored in a memory location. Okay, without forgetting, programs use the user memory, or last time we called the RAM. So in brief, a variable is a named memory location, in which data can be stored and subsequently recalled for use in the program. Hope that is a perfect definition, but I'm not saying that you guys should settle for this. You can always find another better definition, but trust me, it will still lead you back to the same concept. So it's a named memory location in which data can be stored and subsequently recalled for use in the program. Okay, so what do we mean? Variables hold data. Variables hold data. Okay, so if a program is carrying out computations, if a program is carrying out any kinds of evaluations, okay, a way to give you a certain result, a way to give you a certain output, then automatically it has to hold data. And where is it held from? Data is held in locations that are called variables. Okay, now what we call a variable has features. One, a variable should have a name, or what we call an identifier. Two, a variable should have a type, or what we call a data type. Now back to data. If you're storing data, that data should be specific in terms of type. Again, if you're reserving a memory location, that memory location should have a name, and that is why we say identifiers. Basically, an identifier is something in terms of a name that you give to anything. It can be a variable, it can be a function, it can be a class, it can be a structure, it can be anything. For example, I have a name. For this case, it's a nickname, Programmer's Life. So I'm identified that way. Okay, so an identifier. So also memory locations do have identifiers. Okay, so names given to variables. Okay, and when we are giving names to variables, there are certain rules that we follow. One, variable names are case sensitive. Variable names are case sensitive. Two, should carry meaning to the subject. When I say variable names are case sensitive, this is what I mean. I have a variable called age, then the same variable is called age, then the same variable is called age. The compiler will definitely say, please sir or madam, those are three different variables. So mind about the cases. Then should carry meaning to the subject. Whatever you're dealing with in terms of relating, which data are you relating to what? So it means that give a variable name that relates to the meaning of what you're doing. Three, should not be a reserved keyword. I talked about this some time back. Should not be a reserved keyword. If you missed that episode, please go back and try to check out. Should not be a reserved keyword. 4, avoid spaces in variable names. Okay, avoid spaces in variable names. By the way, more rules, more syntactical rules we are trying to mention here. That is why I told you last time that we've outlined a few, but more are going to be coming, and all these have to be kept on your fingertips. So avoid spaces in variable name. Variable names must begin with a letter, not a number, so be cautious of that. Okay, variable names must begin with a letter or a number. Another one, must be declared before use. Okay, shall understand what that means. But basically we are still talking about the two features that each variable should have. I'm not saying those are the only ones, but I'm saying always whenever we hit on something, try to look for more details. Are we together? Then let's talk about what we call a data type. Now data types are known as different formats of data. Okay, data types are known as different formats of data. Okay, and the type of the variable is determined is determined by the nature of data it's to store. Okay, so someone will ask, how do you know the type of the variable? Of course, you're going to know it if you know which type of data it's going to store. Now, C++ as a language foresaw this, or whoever wrote the language, they foresaw this. They foresaw that as a programmer, you're going to write programs that will handle different forms of data. So what did they do? They included what we call data types within the language. Now, C++ has a number of fundamental data types. C++ has a number of fundamental data types. Okay, now these data types have names. Okay, then these data types have what we call units of storage, which are in bytes. Now, each time we talk about unit of storage, each time we talk about storage, then we talk about variables. It means we are talking about memory. It means we are talking about memory. I told you each time we talk about memory, then it means we are talking about RAM. So what does it mean? Now, the computer provides the random access memory, which is called RAM. Okay, what is it for? For storing executable programs. For storing executable programs, as well as data that the program will manipulate. Okay, RAM stores executable programs as well as the data that the program will manipulate. Now, it can be thought of as a contiguous. It can be thought of as a contiguous. Okay, contiguous. It can be thought of as a contiguous sequence of bits. As a contiguous sequence of bits. Contiguous means single chunk. In a layman, single chunk of memory. I think that is how it's a block of memory, but in form of bits or sequence of bits. And each bit, what we call a bit, is the simplest unit of storage in the memory. Okay, I don't want you to get confused. I'm just hinting on this so that you can try to understand. Where am I getting this concept from? I said we have fundamental data types in the language. Each data type has a name and it has a unit of storage in terms of bytes. So I want to show you where this all comes from. So we are saying it's a single chunk of memory but sequence of bits, and we are saying a bit is the simplest unit of storage. So what does it mean? It means that it's capable of storing a 1 or a 0. That is what we call a bit. Okay, a bit is either on or off, or it's either off or on. So we have a 1 and we have a 0, so it's capable of storing data in terms of bits. Now, typically memory is divided into groups of consecutive bits. Typically memory is divided into groups into groups of consecutive. Mark my talking and my spellings. I might not be perfect at spellings, but hopefully you understand. Typically, memory is divided into groups of consecutive bits, okay, and these are called bytes. So when you group a sequence of 8 bits, then you have a byte. So what does it mean? It means that in memory bytes are sequentially addressed. In LMN, what does it mean? It means that every contiguous bit of memory, every single chunk of memory, every sequence of bits, or every grouping of bits, it is addressed. Meaning, back to the definition of what we called a variable, we said variables are memory locations. Okay, we said variables are memory locations. So a memory has what we call an address. So these bytes are sequentially addressed altogether. So meaning each byte can uniquely be identified by an address. In conclusion, each byte can be uniquely identified by an address. This topic is very important because where we are going, variables are going to be the order of the day. So that is why I'm giving it a much better time for us to understand. So back again, we said the language has what we call fundamental types. Now what I'm going to do first here, I'll go to syntax, then choose the language. What do I mean? So we shall have data types here. The first data type is known as int, and int means integer. Now integer, in a layman's understanding, in the basic math that you did, integers mean numbers without points or numbers without decimals, and we call them whole numbers. Now storage can either be 2 or 4 bytes. Okay, storage can either be 2 or 4 bytes depending on the system. So it's a varying type. It's a varying type, meaning it has a varying size basing on the system. One thing that you should know is that some systems are 32-bit systems in terms of registers, then other systems are 64-bit systems in terms of registers. So in your free time, maybe you can try and dig deeper and know what we call 32-bit system and a 64-bit system. Another data type that we have is called a float. Float means floating point. Float means floating point, and for it has 4 bytes. Now someone is going to ask, really, do I need to know the data type and the unit storage? Oh yes. And right now, like I told you earlier, I'm getting everything from my head. So what does it mean? It means that as a programmer, your toolbox, I mean the head, should be equipped as much as possible. Another, we have what we call a double. Now the way you see them in this color here, like the integer, the float, the double, that is exactly the same way we use them in the programs or in the language. So this one is called a double floating point. Double floating point. What do I mean by this? Now earlier we had talked about the float. Now float means it's any value that will have a decimal, okay, at the minimal or at the starting level. Now if that variable is going to have more decimal places, okay, after the radix, or what we call the point or the decimal. You know, for every number that has decimals, for example, I'll jot it down here. I can say I have 556.90 whatever. Now these are what we call decimal places after the decimal. Now if you need a value that has more decimal places than a float, then automatically we are going to opt for a double, and that is noticed in the sizes. So a float already has 4 bytes in the system, then a double has 8 bytes. So why is it a double? It's floating 2 times, okay, so it's a float twice, then you have a double. Then we have what we call a character. I'm going to talk about these data types in more details as we move beyond, but I'm just outlining them and giving you a brief preview of each one of them. Then we have character, and it is shortened as char, and it has 1 byte. It has 1 byte. So it's just a grouping of consecutive 8 bits. So that makes 1 byte, and that is a unit storage of a character. Then we have wchat. Okay, it's another nice unique data type, and this is to handle a wide character. That is what it means. This is to handle a wide character. So the W is for wide, then char, character, okay, and for it it's 2 bytes. So if a character is 1 byte, then a double of it, a wider character, then we shall have 2 bytes. Then we have what we call a boolean. Boolean is bool. Okay, so boolean is the actual meaning, but bool is the usage. So basically this one has 1 byte. Remember, it's 1 bit off. Okay, because we said up here storage sequence of bits, but of course that is zeros and ones. Okay, now if it is zeros and ones, then what does it mean? It means if it's a boolean, then it's either on or off, or true or false in that case. So it's 1 byte of storage. Then we have what we call a void, and a void, this definitely means empty or nothing, or return nothing. And unit of storage, since it's nothing, then we have 0 bytes. Okay, so basically that is where we are for starters. Now we want to understand these data types in a more detailed form, but before we do that, we need to identify the operations on variables. Okay, up there we've talked about them, what they are, the features, well explained down here, and more explanations yet to come. But we need to know what operations can be done on variables. One, variables can be declared. Okay, we have what we call declaration or declared, and up here somewhere, when it came to rules of variable naming or protocol of variable naming, somewhere we said the variable must be declared before use. So declaration is an operation, and we need to know what does it imply exactly. Now when you associate an identifier, we know what that one means, to a data type, then it means you have declared. Just associating. Okay, I have a choice of a name, that is an identifier, 2, I know which type of data I'm going to store, so I know the data type. Then when I join the 2, I have declared a variable. What does it mean? I have to drop a syntax here. So it's gonna be data type, then identifier terminate. Ladies and gentlemen, that is how we declare. Data type, identifier. Examples. What does this mean? I can say int max. Okay, I have a memory location called max and it is an integer. Hey, someone is asking, why did you choose integer? I told you earlier on, what determines the type of the variable is the data that you expect to store. So max, we all know, certainly max are always whole numbers, so that is why I said int max. Once again, I can say int age. I've declared a variable called age of a data type integer, so I cannot say 27 years and 2 months, 0.2. That doesn't make sense. You're 27, you're 28. Okay, so that is why I'm saying int. At the same time, I can say bool answer. Wow, so the answer can either be true or false. I can say char alphabet. You see that? So it means I can have one alphabet, since a character is storing only one. Okay, or I can say double pi. Okay, I can say double pi, or I can say float. Wait, someone can be 30.2 kilograms. So those are examples of variable declarations. We have another operation which is called initialization. First assignment for today, so you guys try to look out for what we call initialization. So back from where we started. Okay, now we said an integer is either 2 or 4 bytes, but commonly in most cases we use 4 bytes. So if I come here and say int max, then finally I say someone got 90 in programming, and finally I say someone is 67 years of age. So what does it mean? It means if I'm to know how much space has been taken by max in the memory, then it's gonna be 90 times 4. Get the answer? Those are the number of bytes. Then I'm going to have, I have 67 or I have here 67 as age. So if I want to know how much age consumes in the memory, then that is going to be 67 times 4. So what does it mean? It means that at this place I have, that is 268 bytes of storage altogether. So basically that is what happens to an integer. Then we have a float, we have a double. Okay, we have a float, then we have a double. So assume somewhere I have a pi. Okay, you can say 3.142 something. I've rounded off, but right here a quick one, we can look for a value of pi that can give us an actual value. Okay, so we have pi, and wow, you see this? So we have quite a value. It's a long value that goes to, I don't know where or how much, but we can pick it up maybe from there. And somewhere I have the value of pi, so definitely that goes to a double because it's bigger than a float. So you can have a float, I can say 64.74. 64.74. Okay guys, so that is how we handle data types. Okay, so much more is yet to come. Having any question for this episode, please try to reach me out on programmerslife@gmail.com, or try to reach me out on 0751824973. I sign out.